All right, we know that trig functions are just some function of an angle gives us a ratio of side lengths. So that is what we've been doing when we found the missing sides. But if we can figure out what the ratio is given the angle, then we can also figure out what the angle is given the ratio. So this set of problems just gives you a bunch of ratios and the functions that they're related to, and then our job is to figure out the angle. So for instance, if sine of theta is opposite over hypotenuse, then inverse sine of that ratio opposite over hypotenuse is equal to our angle theta. The same with cosine and tangent. And so as long as I know the ratio and what function I'm dealing with, then I can just put those ratios into an inverse function and then figure out the angle. So, for instance, on problem 168, it tells us sine of some angle is equal to 0.7193. Well, that's the ratio, and that's the angle. So I can't figure it out like that, but I can do the inverse sine of that ratio. So inverse sine of 0.7193, and that will give me my angle. So I go over here, and sometimes it's called arc sine, sine -1, inverse sine. You'll have to find it on whatever you're using. Mine, I press second and then sine for that little sine -1. I put inverse sine of my ratio, 0.7193. And that tells me 45.99. So that's 46 degrees to the nearest degree. All right, and so it works the same with all the ratios. So if I want to do a cosine problem, then like 165 says cosine of u equals 0.9397. So I can just do inverse cosine of 0.9397, and that will give me my angle. So I go over here and I do inverse cosine of 0.9397. And that tells me 19.99. So that is about 20 degrees. And tangent's the same way. Tangent of A is equal to 0.2867. So inverse tangent of 0.2867 is 15.99, about 16 degrees.